So matter, elements, and atom. Continue notes. So some atoms can lose or gain electrons and form bonds with each other even if they are a living thing. Simple interactions between atoms make life possible. Matter. It refers to anything that occupies space and has mass. All of them are made up of elements and they cannot be broken down to other substances. Elements are designated by chemical symbols, a single capital letter, or it can be an abbreviation in Latin. 4 elements that are common to all living organisms are O, oxygen, C, carbon, H, hydrogen, and N, nitrogen. They make up 96% of the human body. In the non-living world, elements are found in different proportions, and some elements living on Earth are rare. All elements and chemical reactions obey the same chemical and physical laws, regardless if they are part of the living or non-living world. The atom is the smallest unit of matter, retaining all chemical properties of an element. An atom has 2 regions. Number 1 is the tiny atomic nucleus. It's the center of the atom and contains positively charged particles called protons, and neutral uncharged particles called neutrons. 2. Larger, a cloud of electrons, negatively charged particles that orbit around the nucleus. The attraction between the positive protons and negative electrons hold atoms together. We're going to be going over that in the next page. Subatomic particles: protons, electrons, and neutrons. Hydrogen is an exception because there is no electrons. To the number of protons, electrons, and neutrons to the number of protons in the nucleus determine element of atom. Number of electrons surrounding the nucleus determines reactions the atom undergoes, and this is kind of like a diagram. As you can see, the protons is positive, the neutrons is neutral, and the electrons are negative. This is the atom of helium, and it has 2 protons. Protons and neutrons don't have the same charge, but they have the approximate same mass, about 1.67 times 10 to negative 24 grams. Scientists use Dalton or atomic mass unit (AMU) instead of grams. One neutron or proton equals 1 neutron and proton equals 1 AMU. Electrons are smaller than protons and 1 out of 180 AMU. So they don't contribute much to the element's overall atomic mass. This is atom mass, is correct. But greatly affect atom's charge because each electron has a negative charge equals to the positive charge of proton. Uncharged neutral atoms, the number of electrons orbiting the nucleus is equal to the number of protons inside the nucleus. Positive and negative charges cancel out, meaning the atom with no net charge. Protons, neutrons, and electrons are very small, and most of the volume of atoms are greater than 90% of empty space. And most volume of the atom greater than 90% is empty space. So we're going to be looking at a new video on atoms. It's kind of similar to the information before, but it is uncuttable and it's not the smallest form of matter. And there are fundamental particles, like I mentioned before, such as neutrons, electrons, and protons. And as you can see, this is kind of like an image of it. And so as you can see, this is the nucleus, including neutrons and protons, and the electrons are orbiting around the nucleus, but this is actually not in. So you could think of it as crossing it out because it is not a scientific idea. Not a scientific idea. So this is the image I was showing before. So as you can see, as it cools out, it becomes more white, and that white is a cloud of electrons. And usually you can't see it, but using a microscope inside here, you can usually see something like this. So the reds are the protons, and this is the neutrons. Remember, neutrons are neutral, protons are positive. So yes. And generally, a helium doesn't gain or lose electrons. This is a helium atom. It doesn't gain or lose electrons because it is highly stable. It is a highly stable atom being noble gas. You cannot know the momentum and location at any given point in time, but you can know its probability of distribution of where it is likely to be. Orbital, sorry, I spelled that wrong, is the function of where an electron is, and this is how it looks like I mentioned before. Before I forgot, these protons and neutrons are once again inside the nucleus. Coulomb's law is a mathematical description of the electrical force between charged objects. It was made in the 18th century by physicist Charles Augustin de Coulomb, and it is similar to Isaac Newton's law of gravity. And the formula for this law is F equals Ke Q1 Q2 divided by R2. So this means that if two objects have electrical charges Q1 and Q2 that are separated by distance R, then the electrical, meaning the atomic force, is Ke equals Ke9192 over R2. So this is K sub E. This is what this Ke means. This is the electrical atomic force. This is the electrical charges, and this is the distance. And Ke, this approximately equals 9 times 10 to the 9th power, n times m squared over c2. This is Coulomb, and this is Newton meter. Remember, charges can be positive, negative, or neutral, meaning zero electrical charge. The matter can be electrically charged, and like charges repel, remember, opposite charges attract, and closest to charges are the strongest force that is between them. Coulomb's law relates the force between two objects to their electrical charges. So positive is F equals Ke 91 plus 92 plus R2, and these Q and Q2 repel if it is positive. They are repulsive, meaning they're pushing charges away from each other, like I mentioned before. Positive, but these two, so here it was all positive. Here F is positive, but Q1 and Q2 are negative, so they also repel. Here though, F is negative, one of them is positive, one of them is negative, but they are attracted. They attract. And then here, there is a neutral charge, and they don't do anything. There's no force between them. Coulomb's law is an inverse square law, so distances are very important. Another formula for Ke is Ke equals 1 over 4 pi EO, and EO is approximately 8.85 times 10 to the negative 12 C2 over N OM squared. Going back to Khan Academy, further away electron is from the nucleus, it has more and will want to move toward the nucleus, but because of the mechanics and the quantum level, it won't. Based on the number of protons, you can know which element it is. And that is, I'll go and post these online, but these are not all the biology notes, but I converted to the iPad right here. And so I'll go ahead and transition into the iPad on the next video.